Welcome to Empowered Learning. This video will talk about how to graph the greatest integer function inside of WebAssign. So the first thing that we need to do is know what the greatest integer function is, and I call it the stair step function because of how it looks. As you can see here, each one of these little line segments here looks like a stair. And so, of course, it goes up as we go from left to right on the graph. How we actually evaluate this type of function is that whatever x value we have, we kind of do this funny rounding where we round down to the nearest integer. So, for instance, if I had, let's say, now I'll write here on my screen to kind of make my point here. Let's say if I had, let's say int, because that's another way that we write this. We'll write it like that. And clean that up a bit. So int of whatever x is. So let's say if I had int of 0.9, if I was on a real number line and I was rounding down to the nearest integer, that would be 0. Okay. Similarly, if I had int of, let's say, a negative 2.1, then if I round down to the nearest integer, that would actually be negative 3, because I'm rounding down, meaning going to the left. So that's what this particular graph is trying to depict for you, a bunch of points that kind of follow this rule here. So now that we know what the greatest integer function is, I'm going to go to a problem in WebAssign that would actually ask you to graph this kind of function, and we're going to see how we do it. So now we're at our WebAssign problem, and so you can see here the first question is, where is the greatest integer function not differentiable? So we're in a calculus course, and everywhere where our function had a discontinuity, in this case it's a jump, we see that that's a place where we can't take the derivative of the function. So, and that happens at every integer in the function. So the next thing is find a formula for the derivative of our greatest integer function where it is defined. And so it's going to be 0 because everywhere where it is defined, the function is flat. It's like a horizontal line segment. And we all know that the derivative of any constant function or line segment is going to be 0. So next is, how do we actually graph a greatest integer function? Well, we start off by knowing that we're going to have these stair steps, but note here that we have it for this closed interval from -2 to 2. Okay, so at -2, we know that int, or greatest integer function evaluated at -2, will be -2. So we're going to use this particular point palette here to just identify that particular point. Okay, so when x is -2, the value is going to be -2. All right, so that's one way that we could cover this, but a better way to do it is to actually do it this way. And so I'm going to remove this point here and show you a cleaner way to make this happen. So if we go here to our line tool, we'll see that we have a line segment here. And if we take that and then we click here, and then we click here, notice that any number that is smaller than -1 all the way to -2 will actually be -2 whenever we evaluate the greatest integer function. So how we make that happen here is, for this particular line segment, we don't want this point to be defined. So what we'll do is we'll do the drop down here for this segment, line segment, and here at this particular point, which is -1, -2, we're going to tell it put a hole there. Okay. And so by putting a hole there, what we're saying is any number that is less than -1, like -1.1 for x, if we round that down to the nearest integer, it's going to be -2. So all these x values, including -2, will just map to -2 for the y values. Okay. So now that we have that, we see that we have one step in the staircase. We can now create another one. So next thing we can do is go to our next line segment and do one from x equals -1 to x equals 0. And of course here we want it to be defined here. So we're going to have a closed circle here, open circle there. So we come here, and at the point 0, -1, we do open circle, and then we repeat the process again. So we come here, line segment, do that again. We want it defined here at x equals 0, but undefined right here. So again, we'll come and create a hole right there. And then our last line segment will come here and go there, create that last line segment. We want it defined here, but not defined here. Okay. So we're going to make that a hole. And then the very last thing that we're going to do is, since we have all values of x covered from -2 on up to right before 2, here's where we actually use the point and come here and say at x equals 2 is just 2. And so this is how you end up graphing a greatest integer function using WebAssign. So again, you see that for each one of these, and I'm going to expand it out. We just say for each line segment what it is that we want to do. Where's going to be the hole, where's going to be the closed point. So hopefully this will help you be able to understand how to graph these types of functions in WebAssign.